Okay, here's the Steamboat problem. I don't like the problem because it says Mark Twain spots a point on the paddle, and really the point is underwater when he's first spotting the point, but that's kind of beside the point. We want to concentrate on getting the equation of the sinusoidal function. So we're told that the diameter of this steamboat wheel is 18 feet, but it reaches a high point above the water of 16 feet. So we're going to let the water level equal y equals 0. So that means that the paddle or the wheel must go 2 feet below the water in order to have a diameter of 18 feet. And that means the midline is the average of 16 and this -2. So there's your midline right there, y equals 7. And the amplitude is the distance from the midline to the high point or the low point, which is 9. So that's your amplitude. Since the period is 10 seconds, we can find the value of b by saying 2 pi over b equals 10, or b equals pi over 5. Okay. Now, the key to this problem is understanding that there has to be a phase shift, because it only takes 4 seconds for this point that Mark Twain spots to get from where he spots it to the high point. And normally, if we started at 0, it would take 5 seconds because the period is 10 seconds. So, I mean, it would take let's see here, 1, 2, 3. It would take 10 seconds to complete one full revolution, so it would take 5 seconds to reach the high point. So there has to be a phase shift. And how do we find the phase shift? It takes 4 seconds to reach the 16. So we're going to, right now we have this equation. Y could be distance if you wanted. 9 times the sine of, there's b, times the quantity x minus c, that's what we don't know, the phase shift, plus 7. We want to know what the phase shift has to be in order for us to reach a height of 16. So we want to solve this equation for c. So if I subtract 7 and then divide by 9, I get the sine of pi over 2, pi over 5 times the quantity 4 minus c is equal to 1. And that means this expression inside the brackets has to be equal to pi over 2, because that's when the sine is equal to 1. So we want pi over 5 times the quantity 4 minus c to equal pi over 2. And by the way, I'm putting 4 in for t, or for x. And if I multiply both sides by pi over 5, I get 4 minus c equals 5 over 2. Solve for c. There's your phase shift right there. Okay. And by the way, this is the steamboat wheel, this blue circle. And I'll go to Desmos in a minute and show you is that as we move this point along this function, you'll see this point right here on the steamboat move along the steamboat wheel. Okay, but there's your equation right there. You could use t instead of x for the time. And if I actually go to Desmos and move this point along the wheel, I got to change this to t equals 4, let's say. If I move this point along the wheel, or along the sine function, you see that point right here moving along the steamboat wheel. So H is actually giving us the height of that point above the water level. Okay, and there it is. That's when it reaches the bottom point right there. Okay, now let's see what else we got. How far above the surface was the point when Mark's stopwatch read 17? If I go back to Desmos and change this time to 17, we see that the point is at, where is it? I forgot to label this. 4.219. That's the height of that point. 4.219. Okay, how do you do that algebraically? You want to know what is h of 17? You put 17 in for the x or the t. 17 is the same as 34 halves. We're evaluating 9 sine of 31 pi over 10 plus 7. And there it is, 4.2188. Okay, on board 3, there is that height. When t equals 17, the point on the steamboat wheel is 4.219 feet above. And finally, what is the first positive value of t at which the point was at the water surface? We want to know, when does this function equal 0? Now it happens infinitely many times because the wheel is going round and round and round. But the first time will happen when we solve this equation for x or t when the height is 0. So we'll subtract 7, divide by 9, take the inverse sine. So the first angle is the inverse sine of 7/9, but if we solve for x, this is what we get. So the first time that wheel hits water level is at 0.082 seconds. Now if we wanted to find out other times when it hits the water level, there it is right there, hitting the water level. There it is again, hitting the water level. Well, that would happen when we find other values for the inverse sine of -7/9, which we could get. If I call this theta, we could replace that with 2 pi minus theta to get an angle. We could replace that with theta plus 2 pi, going around and around and around. And that's where we say 2 pi k or 2k pi. And we could say the same thing here, plus 2k pi. I think that's the answer to part F. Okay, where we substitute that value into here. Okay, there you go. Hope that helped. I'll ask if you have any questions later. Okay, so I'm going to end the video.